Every Android app you've ever installed has vulnerabilities. The question is whether they're exploitable and whether anyone's bothered to look. Most apps are shipping with hard-coded API keys, insecure data storage, broken authentication, exposed endpoints, all sitting there waiting to be found because developers prioritize shipping fast over shipping secure. Here's how you'd actually test Android apps for vulnerabilities like a professional pen tester. And spoiler alert, it's way easier than you think because most apps have zero security. Before we dive in, if you like the way I break this stuff down and you actually want to learn hacking the right way, CyberFlow Academy isn't just another learning platform. We provide focused, advanced courses in key areas like website hacking, bug bounties, OSINT, reverse engineering, and more. Material that goes far beyond what can be taught on YouTube. Otherwise, I'll get another strike. You also gain access to our active and ambitious Discord community, where you can reach me directly whenever you need guidance. And listen, I know that cybersecurity evolves fast, so I have made a commitment to constantly update the material and add new courses. We already have 500 plus members learning, landing bounties, and applying these skills in the real world. So what are you waiting for? Join through the link in the description and use code CyberFlow50 to get a whopping 50% off, so hurry up. First step is setting up your environment. Install Android Studio for the emulator and ADB, Android Debug Bridge. Get Genymotion for faster emulators if you want. Grab a rooted Android device or emulator because you need root for serious testing. Install Frida for runtime instrumentation that lets you hook into app functions and modify behavior on the fly. Objection, which is Frida on steroids for mobile. Burp Suite for intercepting traffic, and APKTool for decompiling apps into readable Smalley code. That's your toolkit. Everything else is optional. Grab the APK you want to test, either pull it from your device with adb pull/data/app/com.target.app/base.apk, or download from APK Mirror or APK Pure. Run APKTool to decompile with APKTool d-app.apk, and now you have the AndroidManifest.xml showing permissions and components, Smalley code, which is disassembled Dalvik bytecode, and resources folder with layouts, strings, assets. Start with AndroidManifest. Check exported components marked with Android:exported equals true because those are accessible to other apps without permission. Look for custom permissions that are improperly configured. Check for debuggable flag, which shouldn't be true in production but often is. Static analysis comes next. Use JDAX or JDGUI to decompile the APK into readable Java code. Way easier than reading Smalley. Search for hard-coded secrets with grep or manually. Look for API keys often in strings.xml or hard-coded in code. AWS credentials, database passwords, Firebase URLs, encryption keys, Auth tokens, literally anything sensitive developers thought nobody would find. Use tools like MobSF, Mobile Security Framework, which automates static analysis, uploads your APK, scans for common issues, generates a report with findings ranked by severity. It catches insecure data storage, weak crypto, exposed components, code quality issues, everything in minutes. Dynamic analysis is where it gets fun. Install the app on your rooted device or emulator, configure Burp Suite as a proxy, install Burp's CA certificate so you can intercept HTTPS, launch the app and watch all network traffic flow through Burp. Intercept every API request, modify parameters, replay with different values, test for injection, broken authentication, IDOR by changing user IDs, test business logic by manipulating prices or quantities in shopping carts, fuzz everything. Most apps trust client input completely. Test local data storage because apps leak sensitive data constantly. Use ADB to pull app data with ADB shell, then run as com.target.app to access app directory. Check shared prefs for XML files often containing tokens and passwords in plaintext, databases folder for SQLite databases with user data, files directory for cached credentials and API responses. Use SQLite 3 to open databases and select everything. You'll find unencrypted passwords, session tokens, PII, all stored insecurely because developers didn't enable encryption. Root detection is common. Apps check if device is rooted and refuse to run. Bypass with Frida hooks that return false when the app checks for SU binary or test keys in build properties, or use Magisk High to hide root from specific apps. Objection has built-in bypasses with Android root disable, works on most apps immediately. Use Gidra or IDOR IDA to analyze .so files for buffer overflows, format string bugs, insecure crypto implementations. Native code is where serious vulnerabilities hide because it's harder to analyze and developers assume security through obscurity. Tests WebViews for XSS and JavaScript injection. If the app loads web content, intercept the HTML response in Burp. API testing is critical. Most mobile apps are just wrappers around APIs. Test every endpoint for authentication bypass, broken access control, injection, rate limiting, pagination attacks. Fuzz parameters with Burp intruder. Test for mass assignment by adding unexpected fields to requests like isAdmin equals true. Test GraphQL if used for introspection and queried batching attacks. Most APIs have zero security because backend devs assume mobile clients are trusted. They're not. Automated tools help but miss logic flaws. Run MobSF for quick wins, Drowser for automated component testing, QArk for code analysis, but manual testing finds the interesting bugs that pay bounties. Tools find generic SQLi and XSS, humans find business logic flaws like paying negative amounts to add money to your account or race conditions in payment processing. Documents everything with screenshots, requests, and responses from Burp, reproduction steps, impact analysis. Bug bounty reports need clear evidence and reproducibility. Vague descriptions get rejected. Write POCs, proof of concepts, showing exploitation, demonstrate impact, not just vulnerability existence. Legal disclaimer. Only test apps you have permission to test. Your own apps, apps with bug bounty programs, apps you have written authorization for. Unauthorized testing is illegal under CFAA and similar laws. Even if you report findings, you can still be prosecuted. Bug bounty platforms like HackerOne and BugCrowd have mobile programs with legal authorization. Start there. The fun part is every app has bugs if you look hard enough. Developers ship fast, security is an afterthought, code reviews miss things, automated scanners don't catch everything. Learn static and dynamic analysis, understand mobile architecture, test methodically, and you'll find vulnerabilities in apps millions of people use daily. Full Android pen testing course with vulnerable apps and exploitation labs is in CyberFlow's Academy. First link below. Now go break some apps legally.
You still stuck in tutorial hell? We got full courses step by step as well. Web hacking labs, real attack flow, not click here, actually break the code. Reverse engineering, crack moves inside. Gidra open, ego died. Bug bounty methods that actually scale. Find one vuln, that's grocery money mail. $29, that's it, bro. Skill goes up, that's CyberFlow. Python for hackers, C plus Paint. Build your own tools like this, that don't. New course dropping every month. No content drought, we stack it up. Private Discord, killers in chat. Stuck on a bug, we fixed that.